Hi, this is Nicola Wolfe, and what I'd like to talk about today in Neuroimaging Lesson 4H is functional MRI using the BOLD method. So functional MRI is by far the most common functional brain scan, and we're going to use it a lot in future lectures and slideshows because it has tremendous advantages in that it shows detailed structure and the functioning of brain regions during specific tasks. So let's take a look at functional MRI in general and then about how the BOLD method works. So overall, you know from the structural scans that functional MRI uses the same magnetic resonance imaging technology, which shows very good gray-white matter differences. It looks like a slice through a real brain, and it has very high resolution, so good focus. And it is able to, unlike the traditional MRI, to show which areas of the brain are more active, usually in terms of uh, blood glucose utilization or oxygen utilization, and not so much in terms of the chemistry. So that's a disadvantage, is that there's really not very much chemistry that can be done, unlike the PET scan, where you can label a specific ligand and follow its course in the brain. Also, functional MRI is more expensive than things like SPECT or a structural scan. And there's a lot of change in the technology over time, so it's important to have a neuroradiologist who really knows the scan to interpret the result. And people who've ever had these for checking out concussion or usually to rule out brain disorders find that even though we can put a man on the moon, we can't seem to make a functional MRI that's not noisy and somewhat claustrophobic. So some people need to take a little benzodiazepine like Xanax or something to calm down so they can sit through the procedure, or at least get a panic button. So what's the BOLD method? The BOLD is an acronym which is the most common method I've seen published for functional MRI, so that's why I'm going to just review it briefly. It stands for blood oxygen level dependent, and that's a very good acronym actually, because that describes what it's doing. So if you just zoom in on the tiny brain cells in a region of the brain that you want to see its functional activity, uh, in the capillaries, there is, of course, the oxygenated blood is nice and red, and the deoxygenated blood is blue. Now, this brain scan using MRI is not going to be able to pick up the red-blue differences, but it's very clever. It's based on the response of tissues in the magnetic field, and so it is able to draw on the very small differences between the iron in the middle of the heme that carries oxygen in the red blood, and that's slightly different once it gives up its oxygen. So the oxyhemoglobin I showed here in red is responds differently in the magnet to the deoxyhemoglobin, which I've just labeled here in blue. So the way you can remember that, I guess, is that the heme, which is at the center of the blood cell, has an iron in the middle, like an iron filing that it responds in the magnet. And so its immediate environment here about whether or not it's carrying oxygen makes a difference. So when nerve cells are active, they're using more blood locally, and so there's a more rapid change from red to blue, from oxy to deoxy, and the heme changes slightly, and they can use this to show which brain regions seem to be a little more active during specific tasks. So it's very clever technology. It's not perfect. It doesn't have the best temporal resolution. But I wanted to mention that because we will see a lot of scans where they say, this area lights up or is active. And what they're really picking up is a sort of mini way of measuring the blood usage or activity level of individual cells in an indirect way. So that's all I wanted to say about BOLD fMRI, and you'll see other images like this used on various topics in the future. Nicola Wolfe signing off.